Hi, I'm Russell Lowenthal with Oracle's Database Security Team, and today I'd like to talk with you about a threat to your data that you might want to take a look at. When a connection is made to a database and data moves back and forth over that connection, it may move in clear text. When the data moves over the network in clear text, it is vulnerable to someone reading the data as it travels. This type of exploit is sometimes called a sniffing attack. Protecting against sniffing attacks is relatively easy. All that is needed is to encrypt the connection to the database, most commonly using transport layer security, usually referred to by the acronym TLS. When data in motion is encrypted with TLS, it is considered safe against a sniffing attack. This has been the case for many years, but there are technological developments that threaten the safety of that data. Advancements in quantum computing enable attacks directly against the key exchange mechanism that TLS uses to set up the encrypted channel. Using a technique called Shor's algorithm, quantum computers of sufficient strength can crack TLS, exposing encrypted data to attackers as clear text. Most experts believe that quantum computers are not yet sufficiently strong enough to reliably break TLS. But quantum computing is a field that is advancing rapidly, and some estimates believe that sometime between 2029 and 2039, we will see quantum computers that can reliably decrypt TLS encryption. Now, 2029 is still a few years away, so why should you worry about this now? Well, the reason you should be concerned about quantum attacks today is that some attackers are known to be capturing encrypted data and harvesting it, storing it now for use later in the future. When quantum computers are strong enough, fast enough, and inexpensive enough to be used to decrypt the data that was harvested way back in the mid-2020s, your data that is safe today will be clear text tomorrow. What do we do to protect ourselves against these harvest now and decrypt later attacks? Well, the answer is simple. We need to modify TLS to use a key exchange mechanism that is not vulnerable to Shor's algorithm. Fortunately, such an algorithm already exists. The National Institute of Standards and Technology, or NIST, validates that module lattice-based key encapsulation method, or MLKEM, is resistant to a quantum-based attack. Oracle AI Database 26AI includes MLKEM as a configurable setting for TLS communications beginning with the October 2025 release update. With TLS 1.3, using MLKEM, attackers are not expected to be able to break encrypted communications, which makes them very sad, but makes us very happy. To implement quantum-resistant TLS, there are 3 settings you'll need to change. First, you must be using TLS version 1.3, not TLS version 1.2. Second, your cipher suite must be TLS using AES 256-bit encryption and SHA-384-bit checksumming. And finally, you must select MLKEM as your TLS key exchange mechanism. These changes are all made in the database and the database client's SQLnet.aura file. In addition to supporting MLKEM, Oracle AI Database 26AI also supports a new quantum-resistant form of digital certificate that uses the module lattice-based digital signature algorithm, or MLDSA. MLDSA certificates are fairly new, and, at least as of the time I'm recording this, most certificates authorities are not yet offering them. If you're unable to get an MLDSA certificate from your certificate authority, you can create one using Aura PKI. Keep in mind that MLDSA certificates are not required to use MLKEM for key exchange, so this is an optional step. That's really all there is to it. If you'd like to learn more about database security, you can do that at livelabs.oracle.com, where you can get free hands-on experience. We have office hours the second Wednesday of each month where we tell you what's new, and we usually cover some technical topic. And if you'd like to read a little bit more about database security and kind of the things that we think should be done, take a look at Securing the Oracle Database, a Technical Primer. Right now it's in its 6th edition, but we're planning a 7th edition next year. Thanks for listening to me, and I hope to see you during office hours.